Assalamualaikum to Dr. Mahfuzah and all my friends. So today we need to do a video about Fourier transform and filter. So before we start, I want to introduce myself. My name is Rashidan bin Sa'adun and my metric number is 1785555, and I want to share about low pass filter and high pass filter. Okay, so for the first graph, uh, you can see there a graph about frequency response low pass and normalized frequency. Because this is low pass filter, so it will allow the just for low frequency, and this is for the second graph, impulse response of low pass. Uh, it will respond only for the low frequency. Okay, for the third graph, this is the third graph. At the upper, the input is the real input, and at bottom, after we filtered. And for the last graph, okay, this is the graph for input and output spectral low pass. As we know, for low pass filter, it will take the frequency before the cut off frequency. Alright, this is for low pass, and for high pass frequency, okay. This is the first graph for high pass filter. We can see that it will allow just for the higher frequency. For the second graph, impulse response of high pass, it just only respond for the high frequency. And for the third graph, yes, this is the third graph, and at the upper graph, this is the time plots of input and output high pass, and at the bottom is the frequency after we filter it. And lastly, for graph input and output spectra high pass, if the low pass take a frequency before cut off frequency, so for the high pass filter, it will take the frequency after the cut off frequency. So that's all from me. We continue with Mada.
Okay, great. Good morning, to doctor and all my friends. So now I will continue to band pass filter. So from the medic file that I got from the Proctor bus, the cutoff frequency for the low one is 2000 hertz, and the high cutoff frequency is 7000. So now we look at the first graph for bandpass filter. So this is the graph for magnitude, and the bottom graph is for phase. And for the top graph, you can see that bandpass after bandpass filter, the magnitude of the graph in for those the magnitude of the frequency in between the range of the first cutoff frequency and the second cutoff frequency is higher than for those frequency that are out of the range of the two cutoff frequencies. So for the bottom one, the phase is quite constant for those frequency in between the range of the cutoff frequencies, and for those who are the range, you can see that it is not constant and it has many changes on it. So let's proceed to the second graph, which is the impulse response of the bandpass filter. So now, sure, for the positive value of the graph, it will shows like it will towards the positive amplitude one, and for those the value is negative, it will shows negative amplitude in this graph. And for those frequencies who are in the range of the cutoff frequency, it will be passed, and for those who are out of frequency, it will be reduced. So it can be seen clearly that for those who are out of range, it is near to zero, and for those who are in the range, it is show that it has high amplitude than the others. So we proceed to next graph is time plot of input and output bandpass frequency. So this is the input sign for the top graph, and this is the filter signal for the bottom graph. So the formula of the time and the frequency is equals to the 1 over t. So now if in bandpass filter we only allow those frequencies who are in the range, and for those who are out of range we will reduce it. So meaning the low frequency that is lower than the first cutoff frequency, it will be reduced. And after calculating by the formula, it will show like this. The graph will show like this. The highest signal, the amplitude of the highest signal will be close to one or negative one. So for this graph, it is the input and output spectra of bandpass filter. So the top one is the input spectrum, and the bottom one is the filter signal spectrum by bandpass filter. So in between the range of the cutoff frequency, the frequency will shows like it is bigger than those who are out of range. So the graph is can be seen clearly. So this is for the bandpass filter. So now we proceed to bandstop filter. So in the MATLAB file, the first cutoff frequency is 1300, and the second cutoff frequency is 8000. So for bandstop filter, it will only allow those who are out of range from 1300 to 8000 to be passed, and for those who are in between the range, it will be reduced. So let's look at the first graph of the bandstop filter. So you can see that, so for those who are in between the frequency, it is lower than the others. So the magnitude can be seen clearly. It is lower than for those who are out of range. So for the bottom part, it is phase changes, and for those who are in between the range, it's not constant, and for those who are off range, it's quite constant. So for the next graph is impulse response of the bandstop filter. So the graph is almost like this, and this is the highest amplitude of the graph, and for others it is closer to zero. So for this graph, it is time plot, and it is also calculated by the formula of the frequency. And This one is also input and output spectra bandstop filter. So the top one is input and the bottom one is the output of the uh, spectrum. So for those who are in the range of the cutoff frequency, can be seen like it is closer to 0, and for those who are out of range, it has high amplitude than the for those who are in the range of that. So why we need to use a filter in Fourier transform is that if we want to build or create a new improved waveform or any image from the original waveform of or the real part, we need to use the filter. For example, if we want to build a new image that is without high frequency, we can use low pass filter to do it. And after that, it will uh, it will become a waveform that is without any high frequencies. So many one of the reasons that we want to do this is most of us that we don't like the noise, we can use the low pass filter to do this. And from the MATLAB file, at the end we will create 4 wave files that is after filtering by the four types of filter here. And after the low pass filter, the new wave file, it contains no high frequency, and after high pass filter, the wave file is contains only high frequency. And for band pass filter, it only contains the frequency in between the range of a cutoff frequency. And for band stop filter, it only contains the frequency in out of the cutoff frequency. So what is the relationship between Fourier transform and the filter is the product of improved image. The improved image is the product of Fourier transform function and the filter function. And after the after we mix up these two functions, at the end we need to reverse the Fourier transform function and back to the Fourier series. And finally, only we can get the improved image or new waveform from the original part. So that's all for group 1 presentation. So thank you.